So, concluding this set of videos on building the decision trees, I wanted to say a few things. So, first of all, like I said in the end of the previous video, the code which I wrote and which I will share with you is not like a production quality code. So one issue with it is like performance. So the way I'm coding it is just for brevity, for not brevity, but for more exposition to explain what I'm doing, and not to run it the fastest way possible. So it's not efficient. The other thing is the data structure which I used is also not the best for this case, right? I used what is the simplest from what we know in this class, right? Like using dictionaries and so on. There are ways of doing it like more compact. There are issues with a lot of issues with this code. I'm sure there are bugs. Like for instance here in split column, right? So we come here, we say get splits, and then when we that was the place where we're splitting the instance by some column like MPG or displacement in this example. So suppose I'm assuming that if I came to MPG and then I said, okay, give me all the levels of MPG present in this sample I'm using, then I'm assuming there is at least more than one. There's at least two different values, like 21 and 22.8, for instance. But what if I came, like I was splitting, and then I came to the sample where there's maybe a couple of observations and they're all on the same level, 21, 21 MPG. Well, in this case, I cannot split, right? So my splits by default is looking for two values and the value in between. But in this case, there is no split. There is only one value, right? So, okay, then what? So in that case, this code for get splits, like it won't work, right? It'll throw an error. So you have to put some kind of a condition here. So the thing is, like, there's always like these edge conditions, which I didn't think through when I was writing this code. So I'm writing for the most common case. And if you keep running your code, you will run into the situation when in the sample there will not be a split. So you have to put a little condition or something to fix it. So once you start putting all these like funky conditions into your code, it stops being this clear and simple. It becomes more and more complicated, which is fine. Production code should be should take care of like every situation possible in a way, right? But yeah, I'm not doing it here because like for us just to understand the general logic of the tree, it is enough to have this kind of a code. So when you play with this code, just keep in mind like that there will be some situations where it will fail, okay? But again, the main logic of the tree is there. And that's what we've learned, what we wanted to learn in this class is how to actually build the tree using this particular simple implementation of a card algorithm. How to train a tree based on some data set. In this case, it was empty cars, but it can be any data set. You can adjust this code easily, right? So we've learned how to build the tree. Not only that, because we also learned how to traverse a tree which was built for us already. So there's a ready tree which we used with make branches code function in my example, and then how to traverse that tree to make a prediction. And we've learned how predictions are made in the simplest form here, right? So where you're traversing the tree until you reach the leaf node, and at the leaf node you just pick the highest frequency. And that's another thing, by the way. What every time in my example so far, like let's look at some examples here. Um, you know, like this, right? So classes. Every time I did this, the classes always had some kind of a maximum. We would be like at the leaf node, we're picking the maximum frequency and returning it, right? But what if there was two frequencies equal? Then what? So what do you do? How do you predict then? So we didn't account for that situation in our prediction code, obviously. So you'll have to adjust it if you are making it like in a real case situation. But the logic, sort of, we got the main logic there. So we did that. We've learned how to traverse the tree to make prediction. Then we've learned how to actually run the cross-validation through bootstrapping, this random sampling. And actually, the next complication could be for us is to build a random forest or some sort of a bagging, because we have all the elements, right? We're doing bottom-up approach, so we have all the elements necessary. We can build trees on stochastic random sampling of the training sample, which means we can build a random forest now. So you can try to do it yourself. I think I'll create another lab for that, but definitely play with it yourself. It will give you a better appreciation and understanding of how random forest and bagging ensemble learning with trees work. Okay, so this was again, this was all about the classification. And for regression, things work slightly differently, because in regression the cart cost function would have been a bit different. And that is the conclusion of this set of lectures. Thank you.